Hello, hello. Okay, am I live? Hello. I think I am live. Okay, ठीक है. So, hi everyone. So, in this stream, I will be solving Neetcode questions. That's it. I have this list of Neetcode 150 questions, and I'll be solving this. Maybe I can switch it. ठीक है. Okay. Okay. Grinding. यार I'll have to update the thumbnail of the stream. अभी के लिए ये ठीक है शायद से. I'll just check once quickly. एक बार स्ट्रीम सही से चल रही है ना, फिर we will start working on the questions. ठीक है. I think we are good and I can start on the questions. So let's just start. Okay. So we will solve the questions which we have not solved yet. तो एक एक करके शुरू करते हैं. लॉन्गेस्ट रिपीटिंग कैरेक्टर रिप्लेसमेंट. लॉन्गेस्ट रिपीटिंग कैरेक्टर रिप्लेसमेंट. लीड कोड. So I solve the question first on my notebook. So I'll solve it there and then I will code it up on Leetcode. Okay. That is the uh, that is how I'll do this. Okay. So longest repeating character replacement. So let's see. So I know this is a sliding window question basically. I have been given a string and an integer k, and I can change any character at most k number of times. So I have to return the length of the longest substring containing the same letter you can get after performing the above operations. So we have A, B, A, B. Let's say we have A, B, A, B and K is 2. So I can replace B twice. Basically this means that I can have at most K number of, at most K different characters in the substring. Right. Okay. Mm-hmm. So basically I'll have to create the window, and also I'll have to have the frequency map. Okay. So basically what we can do is, so this is the left side of my window, this is the right side of my window, this is the result, and I have taken 10 SK. Okay. Now here I'll store the frequency. Well, R is less than N. What the current character is, character at R. So I'll have to put this. So we thought get or default C plus 1. Now what I can do is see, this is here we will have to add some logic to shrink the window. Now let's say I don't have to shrink right now. Right now I've added A1 and I'm good. So I will say let's move ahead R minus L plus 1 and R plus equal to 1. We can return the result. Now the thing is, so basically I'll have to store the frequency of the character. Basically the maximum frequency of the character. Okay. So I can calculate that here, maximum frequency of the character. And now I will shrink the window if the window size minus the frequency is greater than k. Let's say here basically A is fine, then I come to B, frequency is 1, and the window size is 2. 2 minus 1, 1 is greater than k. No, so we don't have to shrink. We only have to shrink. Basically this is a valid window now. Let's say we have some invalid window where I have to shrink. Okay. Let's say something like this. But k is 2, we can shift a. Okay. Anyways, I mean, we can use this, and now I have to shrink. So we will shrink at L, basically left, and we will update the frequency. And we can improve this. Yeah. So the whole, basically here the idea is we have to keep track of this frequency. This is basically the maximum frequency. And if I'm tracking that maximum frequency, if I'm tracking the maximum frequency, you can shrink the window, and then yeah, I can shrink the window based on this condition, that the current window size minus the frequency should be greater than k, because okay, so at any point we are only maintaining frequency of maximum frequency of chars present in window. Okay, we have submitted this. Let's come here. I'll just mark it as done. 23. So frequency character in the permutation in a string. Let's just see. So we have solved 90 questions. So okay, we have completed 60%. Now let's continue here. Permutation in a string. Permutation in a string. Leetcode. Solving SDE for 66. Permutation in a string. Given two strings S1 and S2, return true if S2 contains a permutation of S1. S2 contains a permutation of S1 or false otherwise. In other words, if one of S1's permutations is the substring of S. This I've already solved or not. Okay. Basically, it has to be substring, but in any sequence, like S1, S1 sequence is not important, but should be present as a substring. Okay. So what we can do is, this is, I'm tracking the frequency of characters of the first string S1. Okay. And then we have to iterate over the window. Basically, we have to prepare the window, prepare a valid window and check. So let me also create the window for the second string, basically S2. So this is it. Now we will see. Now the thing is, if this was present in the original window, which is MP, and into count, so MP dot size is basically the count of characters in the first in S1. And let me also take a temp. So here what I can do is, I can say if this current character was present in the earlier this as well. Also, if their values are same, so p dot get current equals mp2 dot get current. In that scenario, I'll just calculate time plus 1. Now, while so our window size should be lesser than basically should be less than or equal to that S1's size. So if it is greater, we will shrink the window. So let's just shrink the window. S2 dot caret L if mp dot contains key left and basically if I'm shrinking, I'll have to remove its count as well. And then I would say here I'll also update this. Oh, give me a minute. I think there is some issue. Yeah, we are back. So now this is basically I've removed this and here I've updated the account and then we can move ahead. We have shrink the window size. Now what we can say is if temp is equal to count, we can return true. Basically we have also checked that and we have also checked its frequency. Otherwise we can return false. Wrong answer, false, true. Why is it wrong? So 5 test cases have failed. I mean 105 have passed. Okay. See, one edge case is, I mean that edge case should be taken care of by our code, but I'll just add it that if it's the initial string's length is larger, we can always return a false. Still returning false, okay. We are doing fine over here. This is the caret R. I'm adding it to this. If it's already present, I'm calculating this. If the window size is greater than this, we're calculating this. Is I mean, it looks good to me. I'm not sure what the issue is over here. We are shrinking this window. Okay, let it be. I'll just mark this question for now. Let's move ahead. Minimum window substring. This is a hard category question. Okay. Minimum window substring. Given two strings S and T of lengths M and N respectively, creating the minimum window substring of S such that every character in T is included in the window. If there is okay. If there is no such a substring, return the empty string. Return the minimum window substring such that every character in T, including duplicates, is included in the window. Okay. Let me work on this. Minimum window substring. We have this Adobe Code Bank. And ABC is what I have to find. Now let's say I start from this. Okay, left to right. So let's say like my L is 0, R is 0, which basically means that we are at this A. Can I open Excalibur? Yeah. So when we say L equal to 0 and R equal to 0, we are basically pointing to only A. Okay. And now I can say that, okay, basically the original string is ABC. So what I can do is, I can basically core idea is that I will expand my window until I get a valid window, and I'll shrink the window to make it minimum or to keep it a valid window. Okay. So okay, see, I think this is thoda bahut similar to the previous question which we did. Basically, again, if this is greater than this, I can simply return an empty string. I think that's what we have to return, right? Yeah. Now the thing is, what I'll do is, this will count my T, like basically the character count of string T, and to maintain the character count of string S, I am using this. Basically not the string, my window. Okay, window character count, and here I am maintaining T character count. Okay, so now what we can do is char current in T dot to char array. I'll say mp dot put current mp dot get or default current comma 0 plus 1. Okay, now again the count, or we can also call it the required count, is np dot size, correct, and current count is 0. Okay, L0 R0 L0 R0. Okay, now while R less than N, basically N is S dot length. Okay, while R is less than N, char So current character which we are dealing with is this one. Basically, now L0R0 basically means A. Okay. Yeah. So L0R0. So this is A. So we will add it to our current is mp dot put current mp2 dot get our default current comma 0 plus 1. Simply this means that I will add something like A1 in our mp2. Okay, just to give you an idea, mp1 has something like A1 B1 C1. Okay, and mp2 now has A1. Okay, should I just move this here? Yeah. Okay, now I've added it. So we have something like A1. Now I'll see if the original MP had this A and this is equal to this, I can say that current count has increased. So see, I'll just write current count is 0. Okay, but it has now increased to 1. Why? Because this MP has the current and the size is also equal, A1, and this is also 1. So both are 1. So size has increased. So size is also basically the value is also the same. So this is, we are calculating the current count as well. Now we have to shrink the window. Basically we have to write the condition to shrink when we have to shrink the window. In case we don't have to shrink, we can simply increment R. Okay. Now basically when will we shrink? Hmm. See, we have to figure out the maximum, sorry, the minimum window substring, right? We have to figure out the minimum window substring. I'm a little confused right now. If I keep on adding, basically I'll have to shrink the window. Basically I have to find the minimum window substring, right? So if the current count is equal to required count. Okay, yeah. So basically we will keep on, we have increased r to 1. Okay, so now when r is 1, when r is 1, we are talking about AD. Now the thing is, we are talking about AD. Now the thing is, even AD can be like, AD is not a valid answer, but it could be a part of the valid answer, right? And then when r becomes 2 ADO, and then when r becomes 3 ADOBE. Basically, this also is a valid answer. It's just that this is not the minimum, and we have to figure out the minimum. So we will shrink this window if we have found the required count, and then we'll try to shrink the window, like increment L, to see if we can cut something from the left part of the window. Okay, I hope that makes sense. So here what we can do is, basically while current count is equal to the required count, what I would do is, I would say, so I need to write x, let's just say this is -1 and result. Okay, so I'll just say if r minus L plus 1, so this is the current window size. If it is less than whatever the window size I figured out maybe at a later stage, then we will shrink. So I'll store this, and I'll say idx is equal to L. Basically, since I have to return the substring, I'll capture the index. Okay, and now we can get this left character from MP2. I can decrement it. Okay, and you can say since basically we are removing something which is valid for us, I'll have to update the current count with this, and then we can do something like this. Also, since we are incrementing L should be less than equal to R. Okay, now here we can check this is equal to -1, then we return this, otherwise we return substring of this or this. So here also minimum window substring, keep track of me, sorry, yeah, maintain 2 windows and keep track of required count and current count. Okay, this one was also hard. Okay, now let's move forward with sliding window maximum. Okay, sliding window maximum. You are given an array, is it solved? Okay, you are given an integer an array of integers, nums. Okay, there is a sliding window. This is what has been given to me. There's a sliding window of size k equal to 3, equal to 3. So sliding window of size which is moving from the very left of the array to the very right. You can only see k numbers in the window. Each time the sliding window moves right by one position. Returns the max sliding window. Return the maximum sliding. What does the question mean? Max sliding window. 1 3 minus array 1 3 minus 1 3. Yeah, this looks very easy. I don't know why. Then this, so this. We have to return this. I mean, okay. What does the question say? Return the max sliding window. When we have 1 3 minus 1, we are giving 3. When we have 3 minus 1 minus 3, we are giving 3. When we are okay. Yeah, this is easy. I only have to keep track of the incoming number and the outgoing number, and I should be able to figure this out. Yeah, correct. We can solve it. Let me just post the question number in the chat. 239. Okay. Basically, what I'll do is I will use a deck, okay, also called DQ, and what I'll do is that we will have to remove items outside window and insert current index, basically the new one, and we have to calculate the maximum element using the deck, which we can easily do. Okay, so let's start. I just want to see text time complexity. Insertion removal at both ends. Okay, move off one. Okay, let's use this. Now result, we will have k size windows and minus k plus 1. Okay, let's we have this deck. Okay, and yeah, let's start. Actually, we don't have to go to the end. Let's see. Basically, what we will do is we will remove stuff which is not present in the window. Okay, uh, peek first. So what we will do is we will store indexes in the deck. Okay, it will be easier for us because if we store indexes, I can use the peek first to remove the indexes which are not present in the current window. So we are starting from I0, okay, I minus k, and we'll remove this. I'll have to add this check because initially our deck will be empty. Okay, after that I can also remove the smaller elements. Okay, basically nums of p dot p last. If it is less than p, I will remove it. Now apart from that, we will have to add the current index I to this, and one, so I'll have to add the result. So let me just use this. Yeah. Mm. Okay, so index is not valid for, basically IDX is not valid for all, from all i's like 0 to n. Basically I should be greater than equal to k minus 1. Yeah. This is a good question. I was able to solve it right now because I had solved it few days back, but I think it would need some revision to hammer down the concept. The only catch here is that we have to use a deck and we have to store indexes rather than the values. Okay, so we can use a deck and we can remove the indexes which are not present in the window. Also, we can remove the smaller elements. Yeah. Okay, now moving forward, generate parentheses. And this also I solved few days back only. So the constraints are very small, so I'm just backtracking. Basically I've created a resultant string, and initially the string is empty and the number of open and close brackets are 0, and basically if the number of open brackets is less than the given number n, then we add the open bracket and mark it. If the number of closed brackets is less than open, then we close the bracket and then mark this. I mean, this is okayish. It's not tough. It's not easy. Just maintain open and closed brackets count and backtrack. The base condition here is the length of the string if it is equal to the this 2 and 2 cross n. Basically, if we want two balanced parentheses, that would mean 4 characters in the string. So that's when we are returning. We are adding to the result. Okay, I mean this is fine. Let's move ahead with daily temperatures. Okay. Daily temperatures, Leetcode. Given an array of integers, okay, represents the daily temperatures, return an array answer such that answer of I is the number of days you have to wait after the ith day to get a warmer temperature. Okay, ठीक है. Number of days I have to wait after the ith day to get a warmer temperature. If there is no future day possible, keep answer of I is equal to 0. I mean, we are solving the topic stack from the question also. It's very clear we have to use the stack. Okay, so let's say I have a stack okay, let's say I have a stack, and now okay, so basically I mean it's quite obvious that for the last day we will not have a warmer temperature, है ना? So is the number of days you have to wait after that day to get a warmer temperature. So there is no future day, so we keep the answer as 0. So for 73 we know the answer is 0. We don't have a warmer day, but anyways we push 73 to the stack, then we get 76. Okay, now for 76 number of days, okay, number of days I have to wait to get a warmer temperature. So from 76, warmer temperature basically means the temperature should increase. Now 76, if we get 73, that actually means that the temperature is not increasing. Okay, so for 76 also the answer is 0. Now the question is, should we push this? What we can do is we can pop if the current temperature is greater than this. Okay, so what we can do is I'll pop this off. I'll push 76. Okay, can I write a little smaller? Yeah, okay. See, for 72 what happens is this 76 is greater. Okay, yeah, but basically like 72 is the 72 is the 72 is the incoming temperature. So the incoming temperature is not greater than. So we simply push 72 over here. Now I have to mention 1 over here. How do we do that? So essentially I'll have to store the indexes and not the temperatures, because I have to give this, no? I have to give the number of days I have to wait to get the warmer temperature. Okay, so we'll store the indexes. The rest, I think we are good with the logic. So let's prepare a stack. Okay, now the thing is, we will push the index to the stack, and stack is not empty, and the current temperature we are at is greater. Let's say in this scenario, like 76 is greater. In that scenario, I'll have to pop, right? So this is stack.peak. Then let's do one thing. Let's pop it off. Okay. See, what I can do is, let's say I push 73, not 73. I will push the index, no? So I push 7. Okay. And we are not yet updating the result. Okay, result is completely empty. Now the thing is, when 76 comes, we see that the current temperature is greater than 73, right? 76 is greater than whatever we had in here. So for this index, I can say the distance is the index, is this index is the current index minus this index, right? Yeah, okay. So let's say this is 10. Okay, now for now here what we do is, we have let's say I push 6 over here. I minus this index. Array. Okay. See, there's an easier way out. Easier way out is, we will start from this. We'll start from left to right and not right to left. Okay. Now we push 73. Okay, index 0. Then 74. 74 is warmer than 73. Actually, we don't push 73, we push 0. Okay, it's warmer. So we pop this off, and in here I say answer is 1. Okay, Now IC 75, and we also push this IC 75. 75 is warmer than 74, so we pop 1 and the answer for this becomes 1, because this is the current index minus the stuff whatever we have popped off. Okay, now we see 71, so we don't do any pop, we simply push. Okay, so we push. We see 69, we push. We see 72, sorry, we see 72, it's 72 is it's warmer. Okay, warmer than 69, so we pop. Okay, I think we can do it. We are anyway starting from the beginning of this. So what I will do is I'll say stack dot pop, and the result for this index would be the current index minus this. I think I have slightly complicated this logic. It's not that complex, but anyways, I mean, yes, if we start from the end, I could have figured out the solution easier way, in an easier way. But anyways, I mean, this is a good question. This is also an interview worthy question, I think so. So yeah, I think logic is simply monotonic stack. I'll just rate it 1 because I think I spent like I spent longer than I should have on this question. So now let's move forward to car fleet. There are n cars at given miles away from the starting mile 0, traveling to reach the mile target. Okay, target is 12. There are n cars at given miles away from the starting mile 0. You are given two integer arrays, starting mile of ith car and speed. A car cannot pass another car, but it can catch up and then travel next speed at the speed of the slower car or a group of cars. The speed of the car fleet is the minimum speed of any car in the fleet. If a car catches up to a car at the mile target, it will still be considered as part of the car fleet. Return the number of car fleets that will arrive at the destination. Acha, this seems to be a tough question. Okay. Basically, let's say we have this car at position 10, speed 2. So it will reach 12. The car starting at 10 and starting at 8 become a fleet, meeting each other at 12. The fleet forms a target. The car starting at 0, speed 1 does not catch up to any other car, so it is a fleet by itself. The cars starting at 5 and 3 become a fleet, meeting each other at 6. Because its speed is this and its speed is 1. Okay. It moves at speed 1 until it reaches the target. We don't have to tell when will they reach the target. We only have to mention the number of fleets. Basically, how would the cars group up and reach the target? Okay. The cars starting at 0 and 2 become a fleet, meeting each other at 4. 4 travels to 5. It moves at speed. Okay, they can also form a fleet later. I mean, here from 0 it travels at speed 4, 2 travels at speed 2, and they meet at 4. The car starting at 4 travels to 5 during that time, and then the two cars which created the fleet at 4 and speed 2, they reach the car at position 5 become empty, meeting each other at 6. Now this is tricky, I would say. I have to figure out I don't know, this seems like a tough question. Basically, we have this. Let me copy this thing entirely. Eight 53. Okay, let's see. Basically, any car won't be able to overtake. Okay, and if they come together, they become one fleet. Okay, see, position 10, or let's say each car has to reach this position 12. Okay, for the car which starts at position 10, it has to travel two, basically whatever the 2 units with a speed of 2, so it would take time 1. Okay, so time 1. The car which has to reach this, so 12 minus 8, 4 by 4, it will also take time 1. Basically the second car will also take time 1. This car is on this, so it has to travel 12, so it will take 12 time. 12 time basically means maybe 12 hours. Then this car has to travel 7 and it would take 7 hours. This car has to travel 9 and it would take 3 hours. So this is the time each car would take individually. Now the thing is, the slower car would determine the solution, or basically the slower car would like create the fleet. Okay, so this is the position and this is the time. Okay, now give me 1 minute, I'll connect my mouse. Yeah, my mouse is connected. Now what we can do is, so this is position and this is the time being taken. So I'm just sorting by position. Okay, then we have 3. Basically car on position 3 would take 3 hours. The car on position 5 would take 7 hours. Car on position 8 would take 1 hour, and car on position 10 will also take 1 hour. Okay, this is the time, and this is the sorted. Now what I can do is, basically this car is at position 10 and it will reach in 1 minute of time, or 1 hour, let's say. This car is at position 8 and it will also reach in 1 hour. Okay, so let's say this car is a new fleet. So fleet was 0, so we incremented fleet to 1. Okay, and the time it took was 1. Okay, now we see 8 1, so it will also take the same time. Basically this time is same, so this car would join the same fleet 8. Okay, now we have car at position 5 and time is 7. Now this would take 7 hours. Current time we are at is 1. Now this 7 can't reach this one, correct? Which means fleet will increase now. Basically here 2 means that 2 cars were there in the fleet. Okay, I mean I incorrectly incremented this. So here basically now fleet has increased to 2. Okay, and now the time has changed to 7. Okay, now car at position 3, it will take time 3. Okay, so since 3 is less than equal to the current time, so the fleet would not increase, it can catch up. Okay, then we are at T12, so it will take 12. So 12 is greater than 7, so it won't be able to catch up and the fleet would increase. Great, 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 great. I think this solution should work. Okay, so let's just code this up. Yeah, I think we can code this up. So here I'll store the position and the time. So here position is the same and time we can calculate by the this target minus its position, and we can divide by the speed, and then I can try to sort the array. How do I sort it? I can say A0 minus B0. Okay, because we are sorting in increasing order, and this in time is 0, maybe double. Okay, now let's just iterate from the reverse, and if cars of I1 where we are storing the time, it is greater than the time, then the fleet would increase. Otherwise the time, basically fleet would increase, and also we'll update the time, correct? And we can return fleets. Yeah, it should work. Let's see. Cannot infer type, bad return type, double to int, double to int. But if I change this, it will not work. Double dot compare. So I can use double dot compare. This should work, I think. So yeah. Yeah, this was an interesting question, I would say. And I would surely want to revisit it in some time. So basically here the thing is sort by position and time in increasing order and then reverse iterate. Simply, that's it. Nothing new, nothing different. Largest rectangle in histogram. This is marked hard. I'm not sure if I'll be able to do it or not. Largest rectangle in histogram. Okay. Given an array of integers, heights representing the histogram's bar height, where the width of each bar is 1, return the area of the largest rectangle in the histogram. So these are the questions which I've solved way back, I think, when I was preparing for my campus placements. But after that, I've not revised them ever. So, I mean, I don't know if I'll be able to solve it or not. So this is what we have. Okay. This is what we have. Basically, width of each of these is 1. Okay. Basically, I'll have to keep track of the width and the height. Let's say for this, if I say area is 2, if I increase this, the area is governed by the bar with the lesser height and it becomes 2. If I consider this much, basically the entire thing, again it's being governed by the bar with the lesser height, which is 1 into 3, so it becomes 3. So this is basically the brute force. If I keep on doing this, basically the constraint here is arising because of the minimum height bar which we are considering, correct? Yeah, I think we can say so. So for basically, okay. Yeah, okay. I think there's another way to think is, let's say I consider this first bar and I'll try to figure out the maximum of basically the largest area where we have taken this bar. Okay, so if I have taken this bar 2 cross 1, then it's 2. Now I cannot take this bar in this because this will not fit entirely. So for first bar, this is the answer. Let's say for 1, if I see, I can take this, I can take this, all of these. So for 1, the answer is this. So if you see, for a bar, the max area is basically the width where the bar has minimum height. You know, I think this makes sense. Let's say I remove this all. Let's say for let's say 5. The 5 will be a part of this. So it can also be a part of its own. So 5 cross 1, 5. Or it could be 5 cross 2 here, 10. Right? Because we can have this thing. We cannot have anything else. Okay. I think I've understood the intuition. So intuition is simply that for each bar, largest width where the bar is minimum height. Okay. Yeah. This should make sense. And then we can calculate the height and width. Yeah. Now I have to basically calculate this largest width. So we have this. Now let's say we take a stack. Okay. 2, 1, 5, 6, 2, 3. Okay, and stack is empty. Now I push 2. Okay. Basically, I'll try to can you please show me the output? What output do you want to see? I'm sorry, I didn't get your question. Example output. This is the input and this is the output. You can check the question on your system as well. So basically we have been given the heights of certain bars and we have to return the largest area of the largest rectangle which we can form, and width of each bar is 1. Okay. Yeah. So what we were doing is we have the stack. Okay, I push 2. Now in the stack I'll try to keep increasing order of heights. Okay. So 2 is fine. Now let's say when we come across 1 is less than 2, so we pop this off. Now the thing is, this was the maximum height which we saw till date, and width 1. Okay, so we can calculate the area and then we push 1. Then we push 5. Then we push 6. Now we see 2. Okay, Now when we see 2, what we can do is the height was 6. Basically, current value is less than this, so we bring it out and we pop it off. And we can also pop this off. We can't pop off 1. We can push 3, not 3, 2. Now the thing is, when we pop this off, basically how do I get the width? Like, this is the height, maximum height. See, essentially for getting the width, like the width of this is 2, I'll have to basically I'll have to store indexes and not actual values. Basically in the stack I can store indexes. I can store 0 and then I can compare the value. Yeah, if the current height, basically if the current height is less, yeah, basically if it's greater I keep on pushing, if it's less I pop it off. I calculate the height, I calculate the width from the indexes present, and I can get the area. Okay, let's start. I think we can write the code and figure out if there is some issue in our understanding. So I need the stack. Okay, now current height is heights of I. Now simply, basically if the current height is less than the stack's top, I can get its height. Basically I'll pop it off. Okay, okay, I can pop this off and I'll get the height. Basically I push this, I push this. If the current is greater than this, current is greater now, so I push this and now current height is greater than the top. Okay, then we pop and width is width is width would be the current index which I am at minus whatever I had at the top, -1. Now this could be this minus height into width, and I can also push this over here. Empty stack exception. Stack dot yeah, okay. So we are popping it off here. What if it becomes empty? So if stack is empty, go with I. What is the issue over here? You have 2, 4. For 2, 4, we have this 2, 4, and output should be 4. Basically, I think we are not calculating for the last index. That's not working. Basically, the thing is, if we still have values in the stack, basically the stack is not empty. We can follow the similar stuff, whatever we did above. We will pop it off, and width would be, again, this is, I think, same. Rather than n, sorry, rather than I, we will have n. Okay, bye bye. And in here I can calculate this. Yeah, I think that should take care of the last, basically any remaining elements in the stack. That's the okay, done. This is a good question, but in an interview, most probably I won't be able to solve it. Some questions leave us completely blank during an interview. Anyways, binary search. Yeah, this is the worst topic ever to exist in DSA. But anyways, let's start working on binary search. I have not yet touched a single question of binary search. Okay, this will be interesting. Let's move here. Given an array of integers which is sorted in ascending order and an integer target, write a function to search target in nums if it exists. Return its index, otherwise this. So we have been given a sorted. तो binary search की starting point यही है कि हमारा जो array होता है वो sorted होता है. तो यहाँ पे array sorted है और यहाँ पे लगाना ही binary search है. क्वेश्चन से समझ आ रहा है, बट ठीक है, पहला क्वेश्चन है बाइनरी सर्च का. इसके बाद शायद टफ. अरे यार, अबे ये क्या हुआ? What is this? I think I pressed some. अरे यार, क्या हुआ? Okay, okay, I'll see this. I'll fix this later. So for binary search, array is sorted, and I just have to find out now what do I have to return over here. I have to return the index. Okay, I have to return the index. It's very simple. We take an L, we take an R. Okay, okay. L is the leftmost index, R is the rightmost index. When L is less than equal to R, we calculate mid. Now there's a better way I know to calculate mid, but for now I'll just go with L plus R by 2. If it works, it's well and good for me. And if the current number, the mid which we are at, is equal to target, I return mid. Else if the mid where I am at, if it is lesser, like the current value is lesser than the target, so we have to move to the right part, because the current value is less, right? The value which where we are standing right now is lesser, so target is on the right part, basically the bigger part. So we move L to mid plus 1, else we move R to mid minus 1. After all of that, if I'm unable to figure it out, we'll just return -1. तो ये तो बेसिक सा प्रॉब्लम था एक बार एल्गोरिदम को समझाने के लिए। इसके आगे आ जाते हैं। यार ये क्या हुआ, ये मुझे नहीं समझ, ये अचानक से टिक की जगह ऐसा क्यों दिखा रहा है भाई, इसको सही करो। एनीवेज, सर्च अ 2D मैट्रिक्स, सर्च अ 2D मैट्रिक्स। सर्च 2D मैट्रिक्स, तो इसमें क्या है कि you are given an integer matrix with the following two properties. Each row is sorted in non-decreasing order. The first integer of each row is greater than the last integer of the previous row. अच्छा, मतलब basically this is sorted in its entirety. Return true if target is in matrix or false otherwise. ऐसे तो ये m cross n में वैसे भी हो सकता है, but we have to write the solution in log m cross n. Okay, basically entire matrix is sorted. अगर इसको end to end ले कर दें वाया इट्स रो, तो वो पूरा सॉर्टेड है। ठीक है, तो उस अकॉर्डिंग अपन इसको सॉल्व कर सकते हैं। तो इसको एरे बना के सॉल्व कर सकते हैं, तो इसको एरे बना के सॉल्व कर लेते हैं। बेसिकली एरे बनाना नहीं है, एरे जैसा ट्रीट करना है। ओके, तो ठीक है, इसको तो इसमें ज़्यादा कुछ दिमाग नहीं लगाना है, बस एडहॉक है, इम्प्लीमेंट करनी है चीज़ों को। अगेन दिस इज दिस, आर क्या होगा, m क्रॉस n -1, m क्रॉस n -1। अगेन l लेस देन इक्वल टू r। तो ये टेम्पलेट है एक बाइनरी सर्च का। आप l निकालो, आप r निकालो, आप वाइल l लेस देन इक्वल टू r करो, आप मिड निकालो, मिड होगा l प्लस r बाई 2। फिर नाउ अब थोड़ा यहाँ पे आता है कि अब मेरे को नंबर फाइंड आउट करना है ना, तो मेरे को तो रो चाहिए होगा यहाँ पे, बेसिकली रो मतलब आई चाहिए, रो कॉलम चाहिए होंगे। तो रो होगा, इसको थोड़ा एक बार दिमाग लगा के लिख लेते हैं। बेसिकली अगर क्वेश्चन ये था, लेट्स से, ठीक है, तो m is number of rows which is 3 and n is number of columns which is 4, r is 3 4 12 minus 1 11। okay, mid is l plus r, 0 plus r 11 by 2 is 5। I का क्या मतलब है, देखो 0 1 2 3 0 1 2 3 4 5, दिस इज द नंबर वी आर एट। ठीक है, तो रो कैसे निकलेगा, जिस भी हम, जो हमारा मिड है, हमको रो निकालना है ना, रो, इसकी रो नंबर क्या है, वी हैव we have 1357, so rho will be mid divided by n is 4, 5 by 4 is 1, and column will be mod n. Column is quite clear, mod n, uh, 5 mod n is 1, so we are at 1,1, है ना। अब बहुत सिंपल है, अगर मैट्रिक्स ऑफ आई जे इज इक्वल टू टारगेट, वी रिटर्न ट्रू, एल्स इफ मैट्रिक्स ऑफ आई जे इज लेस देन टारगेट, मतलब अभी करंट वैल्यू इज स्मॉलर देन टारगेट, तो हम लोग को टारगेट की तरफ जाना है, तो लार्जर साइड में जाना है, तो एल को मिड +1 कर दिया, एल्स आर को मिड -1 कर दिया, बस हो गया। तो इसमें तो कुछ भी नहीं था, इसमें बस हम लोग को इतना पता होना चाहिए कि ये कैसे कैलकुलेट करेंगे, आई और जे, बस उतना ही था। यार इसको सही करो यार, ये पूरा ही गड़बड़ हो गया, ये क्यों हुआ ऐसा। यहाँ पे टिक आना चाहिए, ये क्या है। लेट मी चेक दिस वंस। Okay, this is accepted. Coco eating bananas. Coco eating bananas. Go to show and check formulas. Okay, okay, ठीक है। अभी कहाँ थे अपन, कोको ईटिंग बनानास पे थे, तो लेट्स सॉल्व कोको ईटिंग बनानास। तो मैंने एक कर रखा है पहले सॉल्व, हमको जितना याद है कि वी हैव टू डू बाइनरी सर्च ऑन द आंसर, बेसिकली आंसर का एक रेंज होता है शायद, एंड उस पर वी हैव टू डू बाइनरी सर्च टू फिगर आउट कि कौन सा करेक्ट वैल्यू है आंसर का, ठीक है। तो इसमें हमारे पास कुछ बनाना की ये पाइल्स हैं, और एच क्या था, ईच आवर विद इन एच आवर्स, तो एच इज 8। ओके, मेरे को बताना है कि उसकी खाने की स्पीड क्या होनी चाहिए, ईटिंग स्पीड। कोको कैन डिसाइड पर bananas per hour eating speed of k. Each hour she chooses some pile of bananas and eats k bananas from that pile. If it has less, she eats all of them and will not eat any more bananas. Coco likes to eat slowly, but still wants to finish eating all the bananas before the guards return. Return the minimum integer such that she can eat all bananas within 8 hours. Basically, उसकी स्पीड क्या होनी चाहिए बनाना खाने की, है ना। तो हमें ये स्पीड बताना है। तो अब इसमें ये होता है कि आंसर के ऊपर बाइनरी सर्च करना पड़ता है, जो भी हमें लग सकता है कि उसकी आंसर हो सकती है। तो बेसिकली मेरे को आंसर है एक मिनिमम वैल्यू और एक मैक्सिमम वैल्यू फिगर आउट करना है, ठीक है। नाउ द थिंग इज कि मिनिमम वैल्यू आंसर की क्या हो सकती है, मिनिमम स्पीड 1, एक एक करके खाओ आराम से, 1 घंटे में खाओ, बट मैक्सिमम क्या हो सकता है, मैक्सिमम स्पीड इज एक बार में, देखो यहाँ पर लिखा है कि वो एक पाइल में के से कम बनाना है तो उसको एक संग खा जाएगी, पर उससे ज़्यादा नहीं खाएगी। मतलब जो पाइल की साइज है वो उसकी लिमिटेशन, मतलब कि यहाँ 11 है, तो अगर उसका स्पीड 11 से चाहे 12 भी हो तो भी वो सबको एक एक करके ही खाएगी, ठीक है। तो मैक्सिमम ऑफ सम पाइल्स ऑफ के तो छोड़ो, चलो जी। तो ये है उसका रेंज, आंसर का रेंज। बेसिकली उसकी स्पीड की रेंज ये हो सकती है ना। अब हम लोग को क्या करना है कि हम लोग इस आंसर के ऊपर बाइनरी सर्च करेंगे, ठीक है, और फिगर आउट करेंगे कि क्या वो एक पर्टिकुलर एच नहीं बोलते हैं, पर्टिकुलर के भी नहीं बोलते हैं, पर्टिकुलर एम में फिनिश कर सकती है। और अगर कर सकती है देन दैट कुड सर्व एज द आंसर। बट क्योंकि हम चाहते हैं कि उसकी स्पीड ज़्यादा हो, तो हम लोग उससे और भी आगे एक्सटेंड करके वी विल ट्राई टू फिगर आउट द बेस्ट पॉसिबल आंसर। ओके, तो अब इधर आ जाओ, इधर आ जाओ, अब इसको कोड कर लेते हैं। तो एज आई सेड कि हम लोग ये जो मिनिमम है उसको ये लेंगे, और मैक्सिमम को हम लेंगे इसमें से निकाल के, जो भी, अरे यार, जो भी मैक्स होगा, ठीक है। और इसको तो आंसर बोल ही सकते हैं, ठीक है। अब हम लोग बोलते हैं एल इज लेस देन इक्वल टू आर, ठीक है। मिड इज एल प्लस आर बाई टू। तो अभी मिड कितना हुआ यहाँ, ये कितना था, ये था, ये हुआ 11। तो हमने एक बार के लिए मिड कैलकुलेट किया है 12/2 6, सॉरी 12/2 6, ठीक है। अब हम लोग ये बोलते हैं कि अगर कोको 6 घंटे में फिनिश कर सकती है, 6 घंटे में फिनिश कर सकती है कितने फाइल्स, एच कितना था, 8 था ना, एच इज 8। एच क्या है, हाँ मतलब मैक्सिमम टाइम, मतलब बेसिकली उसमें गार्ड्स आ जाएंगे। तो दिस इज अ वैलिड कैंडिडेट फॉर अवर आंसर, ठीक है, वैलिड कैंडिडेट तो है। साथ में इसको ऐसे समझो, इन सबको उड़ाओ, ठीक है, कि ये है हमारा एल इक्वल टू 1, और ये है हमारा आर इक्वल टू 12। ये हमारा मिड इक्वल टू 6, एंड वी आर सेइंग कि हाँ 6 घंटे में खा सकती है, 6 घंटे में खाना पॉसिबल है। तो हम लोग ये भी तो ट्राई कर सकते हैं कि क्या वो और, सॉरी ये क्या था, स्पीड है ना, स्पीड, स्पीड इज व्हाट, पर आर ईटिंग स्पीड, हमें ईटिंग स्पीड डिसाइड करनी है उसकी, ठीक है। मिनिमम इंटीजर, हाँ सॉरी, तो मिनिमम बताना है ना हमें। मतलब ये तो चलता है, चलो ये तो चलेगा, बट क्या इससे कम में भी हो सकता है, बेसिकली क्या और कम में भी हो सकता है। तो मतलब हमें इस पार्ट को पूरा उड़ा देना है। पूरा उड़ा देने का मतलब क्या होता है कि इसको ऐसे कर देने का, मिड -1। अब नहीं खा सकती है तो मतलब बढ़ाना ही पड़ेगा ना स्पीड, तो आप बढ़ाओ स्पीड उधर जाके, है ना। और इसके बाद अपन आंसर को रिटर्न कर देंगे। अभी मेरे को ये फंक्शन इम्प्लीमेंट करना है, कैन फिनिश, प्राइवेट बूलियन कैन फिनिश। अब यहाँ पे अपन देंगे मिड इज हमारे अकॉर्डिंग उसका स्पीड क्या है, ठीक है। अब मेरे को ये फिगर आउट करना है वो इस स्पीड में आके फिनिश कर सकती है कि नहीं कर सकती है। तो ये नॉर्मल अपना एडहॉक है, इसमें कुछ बहुत ज़्यादा कैलकुलेशन नहीं है। अपन निकालेंगे कि उसको कितना टाइम इस बेसिकली इस स्पीड से खाएगी, तो कैसे खा पाएगी। तो इसमें है 3 6 7 11 ना, तो लेट्स से 3 है, तो वो एक बार में खा लेगी, है ना। तो उसको कितना टाइम लगेगा ये खाने में? 3 बनाना खाएगी। वैसे बनाना खाने में कितना टाइम लगेगा, बस वही कैलकुलेट करना है, कुछ और नहीं है। 3 बनाना खाने में अगर उसकी स्पीड 6 की है तो 1 यूनिट टाइम लगेगा, इसमें 1 यूनिट लगेगा तो 2, इसमें 2 यूनिट लगेंगे तो 4, और इसमें भी 2 यूनिट लगेंगे। ठीक है, तो वी कैलकुलेट दिस। और अगर कैलकुलेशन में ये जो टाइम है एक्सीड कर जाता है, मतलब कि वो नहीं खा पाएगी कार्ड्स के आने पहले तक, अदरवाइज वो खा लेगी कार्ड्स के आने के पहले तक। तो वही है, सीम्स इजी, तो इट्स डन। आई थिंक ऑलमोस्ट 2 घंटे हो गए शायद स्ट्रीम करते हुए। तो लेट्स सी, आई सॉल्व मे बी 1 or 2 questions more and then I'll close the stream. इट्स अ गुड क्वेश्चन, मतलब इसमें 3 भी दे सकते हैं बट ठीक है। फाइंड मिनिमम इन रोटेटेड सॉर्टेड एरे। Suppose an array of length n sorted in ascending order is rotated between 1 to n times. Might become this. N time results in the array. This. Given the sorted array, find the minimum element of this array. Okay. ठीक है, ये काम करते हैं, अभी रैप अप करते हैं बिकॉज ऑलमोस्ट 2 घंटे हो गए और अभी अब मेरा अटेंशन स्पैन अब धीरे धीरे कम होने वाला है। तो आई विल क्लोज दिस स्ट्रीम। Yeah, I'll close this stream for now. ठीक है, I'll close the stream for now. So maybe I'll continue with this maybe tomorrow. अभी के लिए we check the dashboard. I think we solved 10 questions. I mean, not completely, but we touched 10 questions. क्योंकि I think ये 90 था when we started the stream and now it is 100. तो ठीक है, I don't want to rush. I also don't want to be too slow. अगर मेरे को इंट्यूशन जल्दी से नहीं समझ आता है तो आई ट्राई टू गेट सम हिंट्स एंड सॉल्व इट। तो ठीक है, आई थिंक 50 क्वेश्चंस बचे हैं एंड माय टारगेट इज टू सॉल्व इट विद इन द मंथ ऑफ मार्च, तो वी कैन डू इट। यार इसमें सबसे ज़्यादा टाइम लगेगा बैक ट्रैकिंग में। ओके, टाटा, बाय बाय।